Hello, I'm Kelly Williams. I'll be talking about energy flow in the oceans. I like this slide and I picked this slide because this shows a little bit more of the complexity of the energy flow in oceans. It is a very complicated thing that you could probably talk a long time about. But I like the slide where it shows what you kind of assume it will be, and then the microbial aspect. All these things are so interconnected. They're and very important. As we know, algae, photosynthetic microbes, they use sunlight to produce energy. And also, there's chemosynthesis that goes on, where bacteria use sulfides to create energy near the hydrothermal vents, very, very deep in the ocean where sunlight never reaches. Energy flow is, well, like any system, it is kind of straightforward. You have your producers. In this case, I really like the fact that you have producers using photosynthesis and chemosynthesis. Although there are other places on the planet that happens, not just the deep ocean, but deep in the ocean, nutrient availability is going to be the biggest limiting thing. Um, Oxygen, yes, will always be around in water, but CO2 it gets exchanged through the air so much that getting that deep, that's going to be the one thing I think would probably really limit it. And as you go up the trophic levels, you lose a lot. 90% of energy is lost each step. In oceanic systems, phytoplankton, algae, green plants, and blue green and purple green bacteria, or purple bacteria, are the ones that really do the production. Um, Herbivorous consumers, zooplankton, um, small and young fish will be the next level up. Carnivorous consumers will be larger fish, and then the top carnivores are your sharks, dolphins, albatross, the very large animals in the sea. Oh, there's a whale that doesn't do that, and I really like him for it. All right, photosynthesis. A lot of it happens obviously up close to where as deep as the light can penetrate. So these are going to be shallow waters. In the vast ocean in the middle of it, you're probably not going to have a lot going on with all the other energy that's moving around there, in wind and waves and things like that. But most of it happens in the littoral and Noretic zones, the continental shelf coastlines and shorelines. That's where you're going to find most of it. And near there are going to be algae and the kelp forests. The kelp forests are incredible. They're vast sometimes in some places where we haven't destroyed them. And they're, yeah, largest in size producers by far. Phytoplankton, nanoplankton mainly, are the smallest in size, but in mass, the largest source of productivity in warm waters. And these are all still around the coast. Nanoplankton so small you might not even be able to see them with the naked eye. And these are eaten by the primary consumers, herbivorous zooplankton. And these are in turn eaten by carnivorous zooplankton. Um, these are eaten by larger organisms, and this is what I love. Baleen whales. They are so cool. They are a gigantic organism, and they eat some of the most tiny creatures and can build a mass that big on it. And also, small fish and things like that are going to eat them. And then your bottom feeders, the detritic organisms that really keep us from swimming or living in dead matter. Shrimp, starfish, things like that. Now, chemosynthesis. This I find fascinating. Um, Bacteria that have found a way to harvest energy coming out of these geothermal vents, or oceanic hydrothermal vents, sorry. Um, they have evolved a way to use hydrogen sulfide for energy to produce with carbon dioxide and oxygen sugars, sulfur, and water. And that's fascinating to me. And the giant tube worms in the picture you see here are terrifying, but these are the things that eat that energy, that use that energy, and eat the bacteria. Clams, mussels, Um, so that'll end what I'm talking about. Here are some of the citations that some of the works I used for this, and any questions, type them in there. I'll do what I can to answer them. Y'all have a great one.